All right, in triangle KLM, it says NL, which is this segment right here, NL, is bisecting angle KLM. So if it's bisects the angle, they're identifying that KLN is the same measure as MLN. So these two angles are congruent down here in the bottom. And they want us to compare the ratios of KN over MN. So KN is this segment here, and MN is this segment here. So if I put that ratio down, I'm going to have 10.5 over 7.5. That's Kn over Mn. And then they want us to compare that to KL. KL is this segment over ML, which is this segment. So that's 10 on the bottom, and that is 14 on top. Now we've already seen these fractions, these these ratios happen where there's decimals in the ratio, and the way I told you to handle that scenario is to move all decimals the same number of decimal places over. So one decimal place on top and bottom, this is equivalent to 105 over 75. Okay, if I'm comparing ratios, what I want to do is I want to get both the lowest terms using integers. So the first thing would be get everything to integer form, and then look for common factors to something divide both numbers evenly. Obviously 5 goes in both 105 and 75. If we divide by 5 on top, we get 21. Divide by 5 on the bottom, we get 15. 21 and 15 both divide evenly by 3. 21 divided by 3 is 7. 15 divided by 3 is 5. So Kn over Mn reduces to 7/5. If we look at KL over ML, 14 over 10, both numbers divided by 2, that makes 7/5. So they want us to compare these ratios, and we see the ratios are the same. So this piece over this piece is similar to this piece over this piece. This is just a specific example. Okay, it's not an abstract example, but I will say there's a theorem that states this. If a segment bisects an angle in a triangle, then the pieces of the opposite side are proportional to the sides of the angle. So basically this and this are proportional to this and this. That is going to be an actual useful thing that we can do. So if we have an angle bisector, if we see that picture, an angle bisector, the pieces of the cut side are proportional to the sides of the angle that got bisected. All right. Now with that in mind, the question says, are the triangles themselves similar triangles? Are specifically LKN and LMN, are those similar triangles? Well, if we take a look, the third side of both triangles, because again we have the side congruence postulate, or sorry, similarity postulate. Can everybody see that NL is a side on both of these triangles? And NL equals itself. So the ratio of NL in this triangle to NL in that triangle, so NL to NL, is 1:1. It does not match the 7:5 ratio for the other two sides. So we don't have similar triangles here, but we have a proportional relationship. All right, so if you see this picture in a problem where you have a triangle with a bisected angle, we are allowed to make this proportion. This piece over this piece equals this piece over this piece. That is legal. The triangles themselves are not similar. So that's what you need to get out of this problem. So triangle LKN is not similar to triangle LMN. Anytime you want to not something in math, just use the symbol you would for whatever you do, and then just put a slash through it. So put similar, put a slash through it, means not similar. That gets the job done. So compare the ratios. Ratios are the same. Are the triangles similar? Triangles are not similar.